So we're on question 16. The sales manager of a company awarded a total of $3,000 in bonuses to the most productive salespeople. The bonuses were awarded in amounts of 250 or 750. Okay. So perhaps we'll let X represent the number of $250 bonuses, and then Y represent the number of $750 bonuses. If at least one $250 bonus and at least one $750 bonus were awarded, what is one possible number of $250 bonuses awarded? Okay, so the fact that it's asking for one possible number indicates that there may be more than one right answer. Okay, so let's keep that in mind here. So we know that if we take 250 times X plus 750 times Y, that is supposed to equal 3,000. Right? So the way I figure this is that 250 is the number of dollars awarded in each bonus, and I'm doing X of those, 750 for the 750 bonuses, and I'm doing Y of those. So if I add up that, I should get 3,000, which is the total number of dollars in the bonuses. Okay. Now, let's see. Well, as you can see, I mean, we don't have another equation to use in order to solve this system. So that's why there may be more than one right answer here. So let's try and figure out what numbers might work. Well, for example, right away I'm thinking about Y equals 2, because that would make this 1,500. So if I subtract that, yeah, I think that'll work out. So let's try. So we'll end up with 1,500 here, 250x, and 3,000. So if I subtract then the 1,500, right, then I'll end up with 250x equals 1,500. And I'll divide by 250, and I'll get x equals, these 0 will cancel out here, and then 25. So 6 quarters makes $1.50, so that would be 6. So x would be 6, and that is what they're asking for, the number of $250 bonuses. Next, so for this, I'm going to have to distribute. So I get 6x squared plus 10x, and then I distribute again, so plus 9x plus 15, that's equal to ax squared plus bx plus c. And then I just combine these middle terms, so I get 6x squared plus 19x plus 15 equals ax squared plus bx plus c. And they want to find out what b is. Well, the key thing here is that I have the a's are going to be equal, the b terms, and also the constant term. Yeah, so here the x squared terms are going to be equal, the x terms are going to be equal, and the constant terms are equal. And so effectively we get like 3 equations there. So we get 19x equals bx, and then if we just divide by x, assuming that x is not 0, we end up with 19 is equal to b. Okay. Next question. In the figure above, AE is parallel to CD. Okay. Segment AD intersects CE at B. What is the length of segment CE? So CE is question mark. It's this entire thing. So if we could start by finding out CB, then we can just add and get the total. So it looks like this is going to be a similar triangles question. Okay, whenever we have 2 triangles, especially if they have some overlap or vertical angles, usually that's going to be yes. We can sort of prove it by using angle-angle, right? Since these are parallel lines cut by a transversal, angle D and angle A are going to be congruent based on alternate interior angles. And similarly here, we'll have that fact that these angles are congruent. So we know that these are similar triangles by angle-angle similarity. Right? So the best option oftentimes with similar triangles is to reorient the triangles so that they are in the same orientation. So if I rotate this smaller triangle around 180 degrees, then B would be at the top, D would be on the left-hand side, and point C would be on the right-hand side. Okay, so now it's in the same orientation as the big triangle. So now let me just rewrite the side. So BD is 5, that's here. CB is unknown. And so we can actually set up a proportion using the sides. So 10 is to 5 as 8 is to question mark. Solve for question mark, we get 10 question mark equals 40. Divide by 10, we get question mark equals 4. But we're not looking for question mark, we're looking for the total. And the total of CE would be 4 that we just found, plus 8, which is 12. Okay. All right, last two questions here. So 19. In the xy plane above, O is the center of the circle, and the measure of angle AOB is pi over A radians. What is the value of A? So this angle is pi over A in radians. Okay. We want to find the value of A. Okay, so we want to find out how many degrees, effectively, are in the angle, and then we can convert it into radians. Not too bad. Okay. So, the first step, let's think about what we have here. So we know that this point is rad 3, 1, so the x value would be rad 3. The y value would be 1. Okay. So if we want, we can use some trigonometry to figure this out. Basically, this angle, if I do, for example, a tangent of the angle theta, that would be opposite, which is 1, right, over adjacent, which is rad 3. And if you rationalize this with rad 3 over rad 3, we get rad 3 over 3. And the angle, which has this as its tangent, if you memorize your chart from trigonometry, you'll know that that angle, let's see, is it 30 or is it 60? I think that it would be 30 degrees. Yeah, 30 degree angle. So now we just have to convert that into radians. So to do so, we would do a pi over 180, because pi radians is equivalent to 180 degrees. That gives us our conversion factor. The degrees will cancel out. 30 over 180. We cancel the zeros. 3 over 18 is 1 over 6. So we end up with pi over 6 radians, and therefore A is equivalent to 6. Okay. Question 20. AX plus BY is 12. BX plus 8Y is 60. In the system above, A and B are constants. If the system has infinitely many solutions, what is the value of A over B? Okay. So let's see. The first step that I would take is I would want the right sides to be equal. So I'd multiply through by 5. That would give 5AX plus 5BY equals 60. Right, the reason why I'm doing that is if a system has infinitely many solutions, that means that effectively I have the exact same equation written twice. So that means that the left sides and the right sides both have to be exactly the same. Because remember, each of these models a line in the plane. So, for example, that might be one of the lines, and if I have infinitely many solutions, the second line would have to lie right on top of that line, meaning that they would be modeled by the exact same equation. So I know that these equations have to be identical to each other. And the right sides are now already identical, so I just have to make sure the left sides are equal. So that means that 2x has to match up with 5ax, and also 5by would have to match up with 8y. Okay. Now, I could solve these equations. First of all, I can cancel out the x here, assuming it's not equal to 0. And I can isolate for a. A would equal 2/5. I can similarly cancel out the y, and I can isolate for b. B would equal 8/5. Now I just want to divide a over b, so I can just divide them, and I would flip and multiply, and the 5s would cancel. I would just get 2/8, which is also known as 1/4.